Welcome back to the series of video on update design. This is the third video of the series and this is the last video. In this video, we will cover or we will check how the update design feature works for other modules like beams and foundations. So let's get started. Let us now jump over for the beam design update. So we will quickly go through what all considerations and criteria are specific for the beam design update. So to start with, we have already how the beams are being compared or mapped with the original situation. The next that comes under picture is the level mapping. So whichever level was being selected earlier for designing beams, if the same level is present in the updated or the revised analysis file, then the level will be auto-selected. The next case could be if the level coordinate, say specific to the STAAD file, if the level coordinate has changed, then we need to select the relevant or the related level, and then we can proceed ahead for updating the beam design. If it is an MDB file or if it is a RAM SS file, and if you have changed the story label or the story name in your updated file, only in that case you will be asked to select the level. Otherwise, if the story name or the story label remains same both in your original and updated version of the analysis file, then the level will be automatically selected. Then let us come over to what happens when we are grouping the levels. So if we have grouped two levels in the original file and the same levels are also present in my revised analysis file, then both the levels will be auto selected, and vice versa. If the coordinate has changed or if the story label has changed and we want to group the existing stories, then we have to select it manually. And if in original situation we have grouped the levels, and if in the revised situation or the revised file, if there are some changes in the geometry and if we wish to ungroup the level, then that is also possible. You can go ahead with a single level. The beam mapping parameters we have already seen, that the beam will be a same beam if it lies within the width of the original beam. Then we have some continuity conditions. So say a group of beam which consisted of beams B1 to B5 who had the same width. And in the updated file, we have B1 whose width has changed. So B1 will now be a new beam and it will also be ungrouped from my existing group. As the width changes, the group changes. So now NB1 will be a new beam because the section property has changed, and it will be a new group because it has been ungrouped from the existing group. And if the section property of B2, B3, B4 remains same, now grouping is much more related to the width of the beam. So for B2, B3 and B4, the width of the beam remains the same, hence they stay in the same group. Now for beam 5, my original length of the beam is 5 meters, but in my revised analysis file, the length has increased to 6.1 meters. Now, when the length increases by more than 10%, it is identified as a new beam. Hence, my B5 design will be discarded and it will be a NB2 beam. But this beam will still remain in the same group as my width is same. Hence, this will be a new beam with the same group, and NB1 is a new beam in a new group due to the change in width of the beam. Then, as I have already discussed, that if the section property of the beam changes, that is, if width of the beam changes, then it will be a new design. But if the depth changes, then we compare the freezed or finalized design for the new analysis changes. And if we are making any change in the continuity of the beam in the RCDC itself, like we have various options of modifying the continuity in RCDC, and to the beams for which we have modified the continuity, if the beams are identified as the same beam in the revised case also, then the continuity of the beam will be retained. So at this point, let us start for an actual demonstration by taking some example. So I select the STAAD module, select the beam module, and let us select the beams at 11.2 meter level for designing it further in RCDC. So once the model has been read in RCDC, let us make some general settings, design settings. So let us design the beams for ductile and ductility with intermediate frame, and keep the grades of steel and concrete as C30 and FI 500. And by keeping other settings as default ones, we quickly go ahead and select the load types, add a site, create a set of load combinations, and we proceed ahead for performing the auto design. Once the auto design is done, and say we have finalized on this beam design, after making any modifications if they are required as per the requirement, and the design has been freezed. So we will first save this RCDC file. Let us say 11.2 meter beam design. Once this is done, we can go ahead for updating the design. So the workflow for updating the design remains the same. We need to go to the file menu, click on the update design option, and once the window comes up, we need to select the updated analysis file. So let us select the updated file. Now my level in the original file was 11.2 meter, and the same level has been identified in my revised model as well. So the level gets automatically selected. And so if we want to keep the level same, we directly click on the update project option, and it will bring us to an update design window. So once the data has been read, we can make changes to the preferred rebar spacing, which is dependent upon the width of each and every beam that is present at that particular level. Next step is set the load cases. So there are the 4 load cases which remains the same, and hence the load type is auto assigned and selected. And let us say that we keep the set of load cases same. We can go to load combinations. Now as the set of load cases remains the same, the load combinations will also remain the same, and we can quickly click on update. So now the file is getting updated, and on the bottom left, we can see the groups which are getting updated one by one. So once the update procedure is complete, we get the update design report. Now this update design report gets automatically saved, or a copy of this report is automatically created at the location where we have saved our RCDC file. Then we have the level mapping information, what was the level in my original file versus the updated one. Then which are the new beams that are being identified and which are the missing beams. So this new beams that are being identified are based upon the new location or the relocation that it has undergone. So originally these beams which were lying on the grid 6, they have been shifted considerably, and hence they are identified as new beams, as the center line of this new beam no more lies within the width of the original beam. So we get the data of the new and the beams which have been removed. Okay. Then the sizes and the clear span data. So for the beams whose sizes have changed or for whom the length has changed, we get the data of what was the original or the old length and what is the new one. And then we get the size data also, what was the old size or the original size against what is the new size. And similarly, we get the information regarding the reinforcement comparison also. So what was the old reinforcement versus the updated reinforcement. So that's about the update beam design. Now let us quickly jump over the update footing design. the workflow, the logic, the criteria, and the considerations for the update footing design remains same as that for the column design. So whatever changes or criteria and considerations are done in the column design update, same remains true for the footing design as well. But let us have a quick glimpse of how it actually works. I have created a footing design file, and say we keep different types of isolated footings for different columns. Let us keep these columns on grid 6 as the pad foundations, and let us say the centrally located columns, all these three columns are sloped foundations, and let us consider these three columns as the stepped foundations. Further, let us make some design settings to it. Let us perform the buoyancy, sliding and overturning check, and provide top steel for footing with depth greater than say 800 mm. And we use the cross SBC for design. Let us set the net SBC to say 300 kilonewtons per square meter, and the grade of the concrete as C35 and steel as 500. Click on OK. Let us go to the load cases and assign the load types to each one of them. And we add the load combinations for design. Next, we have to add the load combination for sizing as well. And click on OK and perform the auto design. Once the auto design is complete and say we have finalized upon the design, that is done. Okay. And we want to proceed ahead for updating the design. So we go to the file menu, click on update design and select the revised file. It will go ahead for the update design for footing. So while performing the update design for foundation, so let it be pile cap foundation or let it be an isolated foundation, the changes that can be done at the update stages only with the load cases and combinations. So we just keep the same set of load cases and combinations and we click on update. So now what it is doing in the background is it is identifying which are the same columns and which are the new columns. So for the columns that are identified as the same column, it will compare the size as well as design, whereas for new column, it is completely a new design. So if we see, it is still updating. The update designing footing is still going on. Once the update design gets complete, we will get a update design report. So in the update design report for the footing, the first thing we get is the new columns and the missing columns from the old file and new columns in the new file. What are the changes in the shape or size of the columns? Because the footing design is completely dependent upon the column geometry and forces. So the old and the new sizes or shape will be provided over here. These footings have shifted by a few millimeters. The new CG has been provided and the column number still remains the same and hence the footing number remains the same. Now for the footings whose sizes have changed will be mentioned over here, including the depth change. So for all these footings, the sizes of the footing have changed and the depth of the footing has also changed. And the same information, that is change in reinforcement for top and bottom bars, will also be mentioned over here. So that is from my end regarding the update design in RCDC, which can be performed in different modules. So to conclude on, the workflow remains the same, just the criteria and consideration changes for column and beam. Now, whatever criteria and considerations were taken for column, same applies to the footing update and the pile cap update. whereas there are some differences for update beam, which we have already discussed. With this, we come to the end of the series of the videos on update design. Thank you for watching.